I wish to welcome all of you to our video today. As usual, do not fail to watch, subscribe, like, and share the video. In fact, do not also forget to hit the notification bell such that each time a new video comes, you'll be notified as a subscriber of the channel. In our numbers theory topic today, we are going to focus on the application of Euclid's algorithm and Bezout's identity. What do we mean by Euclid's algorithm? It simply means a set of rules that can help us to find the GCD of two numbers. In other words, the GCD of two numbers is the highest common factor of the two numbers. Let's take, for instance, the numbers 16 and 12. Now, apart from using many other ways to find the HCF of two numbers, suppose you want to use Euclid's algorithm. In this case, we can say that 16 is equals to 12 times 1 plus 4. Because if you divide 16 by 12, we are going to have 1 as a quotient and remainder 4. And then we need to continue by having 12 divide by 4 to give us that 4 times 3 plus 0. That gives us 12. And with this, it is clear that the GCD of 12 and 16 is equals to 4. Now, where does Bezout's identity come into the picture? We can walk back from the question we have to get to something else. But before then, let's take another example. Example 2. Let's find the GCD of 16 and 28. So in this case, we'll say that we'll begin with 28 and divide 28 by 16, and that will give us 1, remainder 12. And then we can now divide 16 by 12, so that will give us 1, remainder 4. We can also divide 12 by 4, that will give us 3, remainder 0. So in this case, we can say that the GCD or HCF of 28 and 16 is 4. Now, how do we use this to solve a problem that involves Bezout's identity? Now, let's go to that part now. Having seen that 0 is equals to 12 minus 12, because 4 times 3 is 12, we don't need that part. Let's begin with 4, where it concerns me and you. Now, we observe that 4, that part is not writing well. Let me get another marker. That 4 is equals to, using the additive inverse of 12, we have 16 minus 12. And then 12 itself is 28 minus 16. Let me write that part. Is equals to 28 minus 16. I mean this. So we can substitute 28 minus 16 in place of 12, since that is equal to 12. So that we now have 4 is equals to 16 minus, here we are supposed to have 12. I now have 28 minus 16. Okay, so if you expand this bracket, we are going to have 16 minus 28 minus times minus will give us plus 16 times 1. Now, what we have is that there is just 116 here, another 116 here, which we can add two of them to have 2 of 16, then minus 1 of 28. So in this solution, Supposing we had a problem, let me say for instance, we're given a problem like 16x, um, 16x minus 28. Let me say is equals to 4, right? And we asked to solve this 28y rather is equal to 4. Then we decided to find the GCD of 16 and this. And then having gotten this, we'll just establish that from here that x is equals to 2 and y is equal to 1. So that is solving a equation like this using Bezout's identity. I am going to do more videos on this and then link it to solving problems in linear congruencies, modular arithmetics in our next video. But we need to do what? Subscribe to this channel, like the video, and then click the notification button and share so that you can have more interesting videos as the days come. Thank you so much for watching.